All right, here's a little help with the lesson 614 making solutions homework. Number one, what do you need to know in order to determine the concentration of a solution? Well, you need to know the number of moles of solute, and you need to know the number of liters of solution. Once you have both of those things, you take moles divided by liters to get your concentration. Number two, define the term molarity. Molarity is the number of moles of solute dissolved in liters of solvent. So it's concentration. It's very similar to number one. Number three, glucose and sucrose are two different types of sugar. Consider these solutions. So we've got 1 liter of 1 molar glucose. So if I take 1 liter, multiply it by 1 moles per liter, I can find out how many moles I've got. I've got 1 mole of C6H12O6 molecules. For the second one, 1 liter of 1 mole per liter sucrose, I've got 1 mole of C12H22O11. And 500 milliliters divided by 1,000, that's 0.5 liters. 0.5 liters times 1 mole per liter sucrose, I've got 0.5 moles of C12H22O11. So which solution or solutions have the most molecules? Well, remember, 1 mole is equal to 6.02 times 10 to the 23rd molecules. So the answer is it's a tie between the first two. Between the first two I'm trying to write. Okay, they both have 6.02 times 10 to the 23rd. Which solution has the greatest concentration? All have the same. They all have 1.0 moles per liter for their concentration. Last question. Which solution has the greatest mass? Well, the molar mass of glucose versus sucrose, sucrose is the bigger molecule. So if you have 1 mole, 6.02 times 10 to the 23rd of the bigger molecule, that one is going to weigh the most. So the middle beaker weighs the most. The beaker, in the middle. Because sucrose's molar mass is larger than glucose's. And the third beaker, it's only a half a mole. So that one would not weigh as much because you don't have as much of the solution. All right. Then we get into making solutions down here in number 4. Describe how you would make these solutions if you were given a bottle of salt. Okay, so imagine this. Actually, I'm going to call it a beaker. Okay, so this has solid salt in it. It's a whole bunch of this is not a solution dissolved in water, just crystals of salt. How would you make 500 milliliters of a 0.15 molar solution of NaCl? Well, first, let's figure out how many moles are in there. So I'm going to take 500 milliliters and divide by 1,000. That means I've got 0.5 liters of solution I want to make. And I want the solution to have 0.15 moles per liter in it. And if I want to make a half a liter, that multiplies out to be, I need 0.075 moles of NaCl. Well, how much does that amount to in grams? 1 mole of NaCl, if you add up the molar mass, weighs 58.44 grams. So 0.075 multiplied by the molar mass gives you 4.38 grams of NaCl. So to answer this question, how would you make this? You would add 4.38 grams of NaCl to a 500 milliliter volumetric flask, just like the ones we used in class. They're very precise when they measure, and fill to line with water. Bottom of the meniscus when you measure. Okay, similarly, how would you make 100 milliliters of a 4 molar solution of NaCl? Okay, same sort of a deal. Divide 100 by 1,000. We're talking 0.1 liters times by 4 moles per liter. That means we need 0.4 moles of NaCl. Multiplied by the molar mass, 58.44 grams for every 1 mole of NaCl. We need, out of that beaker, 23.38 grams of NaCl. So the way that we would make this one is add 23.38 grams of NaCl to a 100 milliliter volumetric flask and fill to line with H2O. Alright, pause here if you haven't done one by yourself and you've just been watching this video. See if you can do this last one on your own. Alright, 2 liters of a 0.05 molar solution. That's 0.1 moles of NaCl. Multiplied by the molar mass, that comes out to be 5.84 grams of NaCl. So for this one, you would add 5.84 grams of NaCl to a 2 liter volumetric flask and fill to the line with H2O. And if you go over, you can't just pour a little bit out because there's some of your solute in there. So that messes with your concentration. You have to start all over again. There's another technique too. What if, rather than being given a beaker of solid NaCl, so the crystals, what if you're given a fairly concentrated beaker of the solution already? So you've got a beaker, it's already got solution in it this time, 0.5 moles per liter. So if you go back in the reading, there's a special dilution formula. It's M1V1 equals M2V2. And the way that works is you put what you have for the molarity, for example, and this is how much you want, and ultimately you calculate how much of that concentrated stuff you would need to add to your new volumetric flask and then fill to the line with water in order to create your new concentration. So it's easier to actually do a problem and then explain it than to try and explain it first. So how would you make a 100 milliliter sample of a 0.25 molar solution? Well, you would use the formula M1V1 equals M2V2 first. So you've got a 0.5 molar solution, and we're going to leave V1 as our mystery. You want to make a 0.25 molar solution, and you want 100 milliliters of it. For this equation, you're allowed to leave volume in milliliters, but just know that whatever number you get when you solve this, you're also going to have units of milliliters. And if you start with liters, then the other units would be liters. I'm going to give myself a little bit more space here for this. All right. So now we've got two sides here, and we've got one variable. We've got the V1. We need to solve for V1. So I'm going to divide both sides by 0.5. Oops, this got thick again. Divide both sides by 0.5. Okay? Now, this is going to cancel out. So in my calculator, I'm going to do 0.25 times 100 divided by 0.5. That comes out to be 50 milliliters. Remember, because the units match. So what does that mean? V1 is 50. Well, that means you're going to have a volumetric flask that goes to 100 milliliters to make your new solution. And you're going to add 50 milliliters of the 0.5 molar, it's called a stock solution, to the 100 milliliter flask and fill to the line with H2O. Now the concentration will be 0.25 molar. So basically I'm going to try and make this halfway. This might be more than half. This is the really concentrated stuff. And then you pour in just water. Okay, this is just my water here. And then you mix it all up. And it makes sense, right? You're putting half of that really concentrated stuff in the new volumetric flask, and you're just diluting it with water. So you're going to make it half as concentrated. Okay, I really ran out of space there. So we're going to have to do this. This is annoying, but got to make more space for this next one. Oops, I guess the words are going too. Okay. Let's keep going. So let's do another example. See if we can make more sense of this. What if you're trying to make 5 liters of a 0.01 molar solution? Again, start with your formula. M1V1 equals M2V2. So your stock solution is still 0.5 molar. That's the stuff you were given. We still don't know how much of that we need. We do know we're trying to make a 0.01 molar solution, and here the units are in liters. We can leave those in liters. Divide both sides by 0.5 to get V1 on its own. V1 in this case comes out to be 0.1 liters, which is the same as 100 milliliters if you times by 1,000. So this time, to make your solution, you're going to add 100 milliliters of the 0.5 molar stock solution to a 5 liter volumetric flask and fill to the line with water. Okay, so a picture of that would be, this would be a big volumetric flask. This line is 5 liters. You'd put in 100 milliliters of the stock solution, and this is all just water. And then when you shake it up and mix it up, you're going to have a 0.01 molar solution now. Alright, now pause if you've been just watching me do this and try to do letter F on your own. Okay, letter F. This time, we're trying to make a, what does it say here? 0.2 molar solution, and you're trying to make 250 milliliters of it. You've still got that same stock solution that's 0.5 molar, and we don't know V1. We don't know how much of it we need. Divide both sides by 0.5. V1 comes out to be 100 milliliters, kind of like the last one. So to make this one, you would add 100 milliliters of the 0.5 molar stock solution to a 250 milliliter volumetric flask and fill to the line with water. Okay, so again, to draw a picture, here's my 250 milliliter flask. 100 of this is going to be the stock solution, and then they're going to fill the rest with water, and then they're going to shake it up, and it will have a concentration of 0.20 moles per